Hello, so in this demo, I'll show how database constraints work in Duckdb using the command line interface or CLI. So I will open my terminal and I'm just making sure that I am the right path. So I need to go in CD into video code along because this is the folder I will be working with. I will CD into this folder called constraints. Once that I am the correct path, I will be setting up a students table in this create SQL file, and then deliberately try to break the rules to see Duckdb enforce our constraints. So to begin with, I have also put the different types of constraints in the markdown file, so I would recommend to check it out. Right, so here I will open my Duckdb CLI and then see that there's a letter D here. That means it is opened. It is ready for any commands. In my create.sql file, I'll create a table, a students table with several constraints. So create table, I could say, it's called students. First column would be, yes, student ID, integer as a primary key. And then we can do name. We can only have text, and I can put a constraint that is not null, meaning that it cannot be empty. And then we can do age, which means it will check the integers that it cannot be below 0, meaning it cannot be negative. And then we can also put email, and we can have a constraint that is the text is unique, meaning we cannot have the same email for different student IDs. It can be empty, so I will not put not null in here. Here, and then we save it. I have saved it, and now back down on the CLI, I can do this command .read and then the name of the file, which is create.sql. So it will read this whole file, which will create a table called students. If it returns a D, it means there is no error. Now we can try to describe this table. Oh, wait, would like to check first if we have a table by checking .table. Yes, so we have created a table called students. It has returned that. Now let's describe the table. Describe students. Right, so now we can see that for each column that we have created, a student ID, name, age, and email, we have the column types that is also in here: integer, text, integer, text, integer, text, integer, text. We can also see that the ones null varchar, so we have made name and student ID cannot be null, but the age and the email can be empty. For the key varchar, we can see that primary is the student ID, and for the email, we have made it unique. So if we would like to see, I would like to see the table itself. Select everything from students. So we basically have a table, but it has no data in it. It is 0 rows. So if we would like to put data in it, what we can do is we can create a new SQL file called insert. And here we can also run, we have two choices. We can run the insert into statements in the SQL file, or we can run them in the CLI directory. But since I want to be able to see and keep track of what I am querying, I always choose to write it here in the SQL file. So I will do insert into the name of the table, which is students. And then we will choose the values. So remember that we have 4 columns. So student name, we can always start with 1. We can have the name Alice. We can have the age 20. And we can have the email alice@example.com. We can also insert another one. Insert into students. Oh, we can do Bob, student ID 2, age 22, and this is the email. So also the reason why that it is important to run this insert statement in a different file is because if we run it here, Duckdb will basically create another table with the insert statements, and that we do not want another table. It's very messy, so it will give out an error, I think. So let's save this one. And I would like to run this SQL file, insert.sql. Aha, did I just do something wrong? Oh no, okay. Dot read insert.sql. Right, so we have run this one. Now we would like to check our table if we have actually created these values. Right, so now we have created them. So this is where we go deeper into the enforcing the constraints. We will check if the constraints, we will check each type of constraints and check that it is actually working. So first, we would like to violate the primary key constraint. We would like to break the rules and see what happens. So we can do that by adding another student with the same student ID as Alice, which is 1. And let's see what happens. I can actually put it here. I will run it in the CLI because I prefer to run it in the CLI when I am experimenting. However, if I am sure with something, then I will run it here in the SQL file. So we can do insert into the table students with the values here. 1, this should give out an error because it's the same student ID, but with a different person. So we can do Charlie, age 21, with charlie@mail.com. We will run it. Constraint error. Duplicate key student ID 1 violates primary key constraint. Yes, we get an error. Duckdb stopped us from having 2 students with the same ID. Now we can try violating the not null constraint. So I'll try inserting a student with no name, which is not allowed. Because looking here, a name that is null is not allowed. All right, so let's do that. I will insert into students with the values of, we can do the third student, so no name. This line should give us an error, the null. We can do age 22, and we can have, okay, eva@example.com. Close it, see what happens. Right, Aha. I forgot to put the quotation marks. Okay, let's do it again. Insert. It gave us a different error. It should have quotation marks. Insert into the table. Students with values. Third ID. The name is null, which should give us an error. 22. And here, eva@mail.com. Right. Now, here is our constraint error, not null, constraint failed, students.name. Duckdb doesn't allow missing values for the name column. So yes, it is working. Next, we would like to violate the check constraint. So I will try adding a student with a negative age with our check constraint that forbids it. So here, if we look our age, it should say that oh no, wrong. Here actually, when we created it, integer is fine, but it will check that the age is not negative or below 0. So we can do insert into students with these values. That is the fourth student. We can call this student David. And the age, that should give us an error, which is -5. And then we can do david@mail.com. Yes, and it gave us a check constraint error. Failed on the table students with expression check. Age is less than. Oh, age should be greater than 0. Yes. Next is we can try to add a new student using the same email address as Alice. So here we would add another student, but the duplicate of this email address, which is not okay. If we're gonna check here, the email should be unique, seeing here. Text, and it should be unique. So what we can do is insert into students with the values of, we can have the 5th, can do Anna, we can do like 24, and now we can do basically the same email address as Alice. So we can do alice@example.com. Yes, this should give us a constraint error, duplicate key, violates unique constraint. So let's recap what our table looks like. Yes, so currently our table looks like this. And just to recap, describe what our constraints look like. So what if we would like to delete let's say that we would like to delete row number 1. We would like to delete Alice's row. So what we can do is delete from students where student ID is equal to 1. Yes, it has no error. So let's run the whole table. Let's check the whole table again and see if student number 1 is deleted. Yes, now we only have Bob left. What if we want to drop this whole table? Then what we can do is drop table, students, the name of the table. And if we would like to check, we can adopt tables, and it should return nothing. So yes, this is basically our lesson for chapter 10, which is enforcing constraints.